Welcome to another deep dive. We're tackling the Rust programming language this time. It's been making quite a splash lately. And you sent us a whole YouTube course on it, so we've got our work cut out for us. But don't worry, we're going to, break it down. Find those aha moments, the things that make Rust so special. Whether you're, prepping for a meeting or just curious, we're here to guide you.
Exactly. We'll cut through all the tech jargon, make it make sense.
Perfect. So the video jumps right into installation using something called Rust Up. Sounds straightforward enough, like a command line tool that handles all the different Rust versions and components, I guess.
Yeah, it's your Swiss Army knife for Rust. Keeps everything organized, make sure you have the right tools.
Gotcha. And then we get the classic Hello World program, programming 101. Gotta start somewhere.
It's like the first handshake with Rust. And the video shows how you use cargo run to compile and run the code, which highlights the role of cargo. That's the package manager, by the way.
So cargo's like the stage manager, making sure everything runs smoothly behind the scenes.
Exactly. And here's where things start to get interesting. Rust is statically typed. So you have to be specific about what kind of data a variable holds. Like, is it an integer, a float, a Boolean, that sort of thing.
Right. But why is that such a big deal? I mean, other languages are more flexible about data types.
Well, it's one of the ways Rust helps you write safer code, more efficient code, too. By defining those data types, the compiler can catch errors early on. It's like a spell checker, but for types, not typos. Catches those mismatches before they become problems.
That makes sense, preventing those late night debugging sessions.
Exactly. And think about memory efficiency. Different data types use different amounts of space. Being explicit about those types, it lets you optimize how much memory you're using, which is especially important when resources are limited.
Yeah, starting to see how those seemingly small details can really add up. So we've got our basic data types, but what about storing multiple values together? The video mentions compound data types. Things like arrays, tuples, slices, and strings.
Right. Compound types, they're essential for managing those collections of data. Arrays are like containers that hold a fixed number of values, and they all have to be the same type. Tuples, similar, but they can hold different types.
Okay, arrays and tuples, I'm with you. But slices, those are a little more mysterious.
Imagine you have a loaf of bread, right? And you want to share, but you don't want to give the whole loaf away, just a couple of slices. That's what slices are. In Rust, they give you a view into part of an array without copying the whole thing.
Ah, okay, that's a great way to put it. Slices let you work with just part of an array.
Exactly. And then strings. Now, strings in Rust, they're a bit more complex, not just simple arrays of characters like in some other languages.
Yeah, they're designed to handle a wider range of characters, right?
Exactly. For the demands of modern software, all kinds of text from all over the world. Now, let's shift gears. Talk about functions, the building blocks of reusable code. In Rust, you define a function with fn, followed by the function name. Snake case, of course. Then any parameters it takes and what it returns.
Right. Functions are like mini programs within your program, right?
Yeah.
They make your code more organized, easier to understand.
Precisely. Breaking down complex tasks, making them more manageable, like chapters in a book, easier to digest that way.
That makes sense.
Yeah.
The video also mentions this distinction between expressions and statements. I'm always a little fuzzy on that.
Okay, so an expression is like a mini calculation that produces a value, like 5 plus 5 that evaluates to 10. A statement, on the other hand, it performs an action, declaring a variable or calling a function, for example.
Okay, expressions are about values, statements are about actions. Got it. Now, are you ready for something truly unique to Rust?
I think so. Bring it on.
Okay, ownership. It's a core concept in Rust, and it's what sets it apart from a lot of the languages, and it's key to its memory safety guarantees.
Okay, I'm intrigued. Tell me more about this ownership thing.
Imagine you lend a book to a friend. While they have it, they're responsible for it, right? They can read it, lend it to someone else, even donate it, but they can't have two copies at the same time. That's kind of how ownership works in Rust.
So every piece of data has an owner, and only one owner at a time.
You got it. And it might seem restrictive, but it actually prevents a lot of common errors related to memory.
Okay, starting to see how that could be powerful. But what if you need to, share data between different parts of your program?
That's where borrowing and references come in. It's like letting someone borrow your book. They can read it, but they have to give it back. In Rust, references let you access a value temporarily without actually taking ownership.
So borrowing is like a temporary handover of data, while ownership is more permanent.
Precisely. And this whole system, With ownership, borrowing, and references, it's what makes Rust so safe. Prevents issues like dangling pointers, where you have a reference to data that's gone, or data races, where multiple parts of your program are trying to modify the same data at the same time.
Okay, this is starting to click. It's like Rust has these built-in safeguards.
Exactly. Now let's talk about another feature that contributes to Rust's safety. Mutability.
Mutability, so like whether you can change a variable's value.
You got it. By default, variables in Rust are immutable. They can't be changed after they're initialized.
Wait, so everything's locked down unless you specifically say otherwise.
You got it. It might seem like an extra step, but it actually makes your code more predictable, prevents those accidental modifications.
So it's about being intentional, preventing unintended consequences.
Exactly. But what if you do need to change a variable? Well, that's where the mut keyword comes in. Add mut before a variable, and boom, it's mutable. You can change it.
Okay, so immutability is the default, but you can opt in to mutability when you need it.
Right. It's like Rust is encouraging you to think carefully about when and where data should be modified. Now, alongside mutable variables, we also have constants.
Ah, those are like the fixed values in your program, right? Mathematical constants, config settings, things like that.
Exactly. Declared using const, they have to have their type specified, and they're usually named in all caps with underscores. They're useful for, things that really are constant, never going to change.
So constants are for the unchanging foundations, while variables give you flexibility where you need it.
Got it. And then there's this concept of shadowing, which sounds a bit, shadowy.
Yeah, shadowing is when you declare a new variable with the same name as an existing one, but in a specific scope. Like creating a new version of that variable, but just for that part of your code.
Interesting. So what's the advantage of that?
It can make your code more readable, better organized. You can reuse variable names without creating conflicts.
Ah, I see. Like using the same word in different sentences, the meaning might change, but the word itself stays the same. Exactly. It's like decluttering your code, repurposing existing labels instead of adding new ones.
Love that. Okay, before we move on to control flow, which I'm excited about, there's one more fundamental thing we need to cover. Comments.
Ah, yes, comments. Those little notes you leave in your code to explain what's going on, even though, the compiler completely ignores them.
Right, but they're essential for making your code understandable to yourself and to others. In Rust, you can use for single-line comments, or you can enclose your comments in for multi-line comments.
It's amazing how much a well-placed comment can help. It's like leaving breadcrumbs for anyone trying to follow your logic, including yourself, 6 months down the line.
Absolutely. Good comments can transform a confusing piece of code into like a beautifully documented masterpiece. Okay, ready to dive into how Rust manages the flow of your program? Control flow.
Absolutely. Conditions and loops, they're the backbone of any programming language.
Right. And Rust handles them in ways that are, both familiar and unique. Let's start with conditions. Rust uses if, else, if, and else to execute different blocks of code based on certain conditions.
It's like checking if a number is divisible by 4, 3, or 2, right? Just like the outline mentions.
Precisely. Conditions act like decision points in your code, guiding the flow of execution. And you can even use them in let statements to assign values based on a condition.
So it's all about controlling which parts of your code get executed based on the situation.
Exactly. Now, onto loops, the workhorses of repetitive tasks. Rust gives you 3 main types: loop, while, and for.
So loop is for when you want to keep doing something indefinitely until, like, a specific event happens.
You got it. It keeps checking a condition, and as long as it's true, it keeps running the code inside.
And for loops are for those times when you want to go through a collection of items, like an array.
Precisely. They streamline working with each element in a collection one at a time.
Okay, starting to see how these different loop types give you a lot of flexibility.
They do. And they connect back to those concepts we talked about earlier. Data types, variables, mutability.
It's like all these pieces starting to come together.
Exactly. Now, are you ready for another unique aspect of Rust? Enums. They're custom data types that can hold one of several defined variants.
So enums are a way to define a set of possible states for a variable.
You got it. It adds structure and clarity to your code because you're limiting the possible values a variable can have. Think of a traffic light. It can be red, yellow, or green. but nothing else.
Ah, it's a perfect analogy. So enums are like defining a small universe of possibilities.
Exactly. And in Rust, you can even attach data to each variant, which adds another level of flexibility.
Okay, I'm seeing how powerful enums can be. I feel like there's a lot more to explore there. But you know what? I think it's time for a break. We'll be back soon to continue our Rust adventure.
Welcome back. We've covered a lot of ground, variables, data types, even touched on that fascinating concept of ownership.
Definitely a lot to take in, but I'm ready for more. What's next on our Rust journey?
Well, let's talk about how Rust handles collections of data. You know, those structures that let you store and work with groups of values. The outline mentions vectors, strings, and hash maps.
Sounds essential. Let's start with vectors. What are they all about?
Think of a vector like a supercharged array. It can hold a bunch of values, all the same type, but here's the cool part. It can grow dynamically. You don't have to know the size beforehand.
So it's like an array that's always ready for more. No more worrying about like overflowing a fixed size container.
Exactly. The video shows how you create a vector using the vec macro. It's a shortcut, basically. And you can add elements using push, like you're pushing items onto a stack.
Okay, creating and adding seems pretty intuitive. What about accessing elements? Is it like arrays where you use an index?
Yep, you can access elements by index starting from 0, just like arrays. But remember,
I know,
Rust uses that here too to prevent you from accidentally accessing an element that doesn't exist.
Oh, right. So instead of crashing, it makes you handle the possibility of like nothing being there.
Precisely. Makes your code more robust, you know? You're anticipating those potential errors. Okay, let's move on to strings. Remember how we said they're a bit more nuanced in Rust?
Yeah, they're not just simple arrays of characters.
Right. They use UTF-8 encoding, which means they can handle, like, text from all over the world.
Makes sense given how globalized software is these days. You need to be able to handle all kinds of characters.
Exactly. Now, the video mentions 2 ways to represent strings, string and *.
Okay, I'm curious about the difference.
So string is the owner of the string data. It's allocated on the heap, which means it can grow dynamically. It's what you use when you need to, modify a string or store it for later use.
Gotcha. So string is like the full-fledged dynamic string type. What about ** then?
*, that's a string slice. It's like a lightweight reference to a portion of a string, like borrowing a page from a book, but you don't own the whole book.
Ah, so slices are more efficient if you just need part of a string.
Exactly. You're not copying the whole thing, which can be a big performance boost, especially when dealing with lots of text.
And I'm guessing Rust's ownership rules play a role here too, making sure that string data is managed properly.
Absolutely. It's all connected, ownership, borrowing, references. It's all designed to make sure strings are handled safely and efficiently.
Rust really seems to have thought of everything when it comes to, like, memory safety.
Okay, ready for the final collection type? Hash maps. They're like the champions of key value storage.
Hash maps, yeah. Those are like dictionaries or associative arrays in other languages, right?
Exactly. You store data as key value pairs, like a phone book, You use the name to find the phone number.
Classic analogy. So in Rust, hash maps are the way to go for these lookup tables.
Precisely. They use a hashing function to map those keys to their values. Super efficient. The video shows how to create a hash map using hash map, and then you use methods like insert to add pairs and get to retrieve a value based on its key.
And I bet get returns an option again, right? Just like with vectors.
Yeah.
Always got to handle those potential errors.
You got it. Rust's error handling, it's consistent across different data structures, always emphasizing safety and robustness.
I'm seeing a definite pattern here. Rust really wants you to write code that's not just correct, but also super reliable.
You got it. And there's one more thing about hash maps worth mentioning. Remember our earlier discussion about security? Well, the hashing algorithm Rust uses, it's specifically chosen to help prevent certain types of attacks.
Wow, so even the hashing algorithm has security implications. Never thought about that.
It's a good reminder that security is, it's everywhere in software. Even seemingly small details can matter, and Rust takes it seriously.
This deep dive is really showing me how much thought has gone into the design of Rust. It's impressive.
It's a language that makes you, really think about every aspect of your code. Memory management, error handling, security, it's all connected.
I'm feeling a lot more confident about tackling Rust now. What's next?
Well, now that we've got a good handle on data types and collections, let's talk about those inevitable hiccups in software, errors.
Error handling. Given Rust's focus on safety and robustness, I'm guessing it's got a unique approach to this too. Let's Let's dive in.
Okay, let's talk errors. Those moments where things go wrong. I can't avoid them completely, no matter how good a programmer you are. So how does Rust help us, handle those situations, keep our programs from crashing?
That's where Rust's error handling comes in. It's pretty unique. Remember those special enums we talked about, option and result? They're like built-in safety nets.
Right. Option was for dealing with cases where, like, a value might not exist. You might have it, you might not, like checking your pocket for your keys.
Exactly. Option makes you think about both possibilities. Instead of crashing if the value isn't there, you handle both cases. Some when you have the value, and none when you don't, like packing for, all kinds of weather.
Always be prepared. So it's about anticipating problems, having a backup plan. What about result then? When do we use that? Result is for those times when an operation might succeed or it might fail, and you want to know why it failed, like reading a file, making a network request, even just dividing by 0. Lots of things can go wrong there.
So result gives you more information about the error, whereas option just tells you whether a value is there or not.
Exactly. Result has 2 variants. Okay, which, wraps the successful result, and error, which holds the error, explains what happened.
Like ordering something online. It either arrives or you get a notification saying why it didn't.
Perfect analogy. It's like Rust is saying, hey, don't assume everything's going to work perfectly. Think about what could go wrong and be ready to handle it.
Makes sense. Be prepared for the unexpected. Now, the video also mentions this method called unwrap. That one always sounded a bit risky to me.
Yeah, unwrap, it can be dangerous if you're not careful. Like, you're assuming that the value is there, and if you're wrong, boom, the program crashes.
Why would you ever want to crash your program?
Well, imagine you've already checked for errors, like a bunch of times, and you're sure they won't happen in that specific part of your code. Unwrap lets you skip all the error handling and just grab the value directly.
But if you're wrong, well, things go boom.
You got it. It's a trade-off. Rust gives you all the tools to handle errors gracefully, but it also gives you the freedom to be, more direct if you're confident in your code.
So it's about making informed choices.
Right.
Based on your understanding of the code and how much risk you're willing to take.
Precisely. And that brings us to the end of our whirlwind tour of Rust. We've covered a lot, from the basics of, variables and types to those unique concepts like ownership, borrowing, and error handling.
It's been quite a journey. I've learned a lot. It's amazing, really, how much thought has gone into making Rust both powerful and safe.
That's Rust in a nutshell, really. It might seem a bit strict at first with all its rules, but those rules are there to help you write code you can trust. Robust, reliable, efficient code. And that's a good thing, right?
Absolutely. So, to our listeners out there, keep exploring Rust. It's a language that, rewards curiosity, makes you think differently about how you write software. And that's what makes it so exciting.
Happy coding, everyone.